right, guys. So get this out. You can use your notes if you need to, but I'm gonna walk you through this. You will turn this in tomorrow. Okay. If you got a hang of it, you can move ahead and just check as we go. But you are gonna always complete the proof by first listing the given. So it says that right here. You're gonna start off with your given. Oops, I probably should have did that a different color. But then it says you're going after that. You need to choose from the following reasons. So if you look at this little section right here, this is like your word bank that you're gonna use to fill it in. Okay. So if you get lost, try to pick one of these options up at the top. All right, so I'm going to color code. That's up to you if you want to do the same. But what we have first, let me go right here. Line 1 is always a given, and they've already started the statement for us. Right here, they got it up here. It says AE bisects BD. Our reason is given. So AE is bisecting the segment BD. This segment BD is getting cut in half by the AE. So that means you have to add a tick mark between B and C and C and D. Notice that what we just marked, they gave the statement for us in line 2. BC is congruent to CD. My reason for that, if you look up here, we have definition of bisector. So I'm just going to abbreviate that. I'm going to pick this reason up top, and you're going to use them more than once, okay? So definition, I'm just going to put DEF of bisects or bisector. Well, then if you look right here in line 3, it says BD bisects AE. That was at the top at the given as well. So I'm going to fill in the reason as given. So I need to show that because this segment right here, this AE is getting bisected. So I'm going to put 2 tick marks between A and C and E, which is also the statement in 4. AC is congruent to CE. So guess what this reason is going to end up being? Yep, the same one. Definition of bisector. Okay. Now, line 5 says angles ACB are congruent to ECD. I don't know if you see, but those are these vertical angles right here that they're naming. And vertical angles is one of my reasons at the top. So I'm just going to abbreviate vert and then put the angle symbols. Vertical angles are known facts that you have to mark. All right, line 6 is always what we're trying to prove. So we're trying to prove right here that the 2 triangles are congruent. So that had to go in line 6, but it does. So we have to pick out of one of these 5 ways over here. It is SAS. Good. And then we're done. Okay. The last line has to be what we're trying to prove. Now, on number 2, because we have some overlapping, some people are kind of getting the which triangle to focus on. I'm going to start off with this given where it says AD, that segment AD is congruent to BC. Okay, that is always in line 1, the given. So AD is this whole line, but I'm going to put the tick mark here because I got to see what triangle they're trying to, because we're looking at triangle ABC. So this line and this line, okay? Then if I read line 2, its statement says AC is congruent to AC. That's the same expression. That is a reflexive property, yeah, and I can abbreviate that as well. Because AC is the shared side, so I'm going to put a double tick mark there. Then here, line statement 3 says angle ACD and angle CAB are right angles. Well, that means I need to put a box to show it's right. So I'm going to put a box at A and at C. And I got this information on this line from the given. Well, they want us to prove the 2 triangles are congruent. And because I see this right angle, if I look opposite that, That is the side that I have a marking on, which is the hypotenuse. So this is by HL. Okay. So you are going to have some that are overlapping. So you just kind of might have to separate them or color code it or highlight it to help you see. All right, let's look at 3. First 2 lines say given right there already. So I just need to copy what they gave us. They gave us angle NIO is congruent to angle NGGD. Sorry. Now, if they state it, you still need to mark the given on the diagram. So because I have 3 letters here, let me fix my font. NIO, you stop at the middle letter, the I. So put an arc at I. And NGD, we're going to put an arc here at G. They also tell us that NO, this side NO, is congruent to ND. NO, I probably should have done that in a different color, but NO is this whole side right there. So I'm just going to put tick mark there and ND. Tick mark there. Now line 3 says angle N is congruent to angle N. What's our reasoning for a statement like this? Yep, it's always reflexive property. Good. Because that is indicating N is the shared angle. So I put 2 arcs at N. So line 4 wants us to prove that triangles are congruent. I'm not sure if you can see this triangle I and O. There's an angle here at I. There's an angle at N. And then there's a tick mark at NO. This is by angle side. So the last line is always what we're trying to prove, which is right there. And that's right there. What would be our reason for this last statement? Very good. C, P, C, T, C. Say it fast. Oh, you got it today, huh, Josh? Right. Okay, so on number 4, start off given. Always given is the first line. And I see it right here. RS is parallel to TA. So I need an arrow and an arrow. And if you have parallel, then now you can mark what? What do you have to mark with parallel? Alternate interior. So we should do the alternate into this arrow and this transversal at R, which if you look, that is TRS. And then right here at T, the ATR or RTA, okay? So our reasoning for those 2 angles, or stating those 2 angles, would be alternate interior angles. If you're not sure too, remember your choices are up here, okay, that we're pulling from. All right, line 3 is another given statement. So if I look right here, there's our second given statement. They didn't go in order. It's okay, you don't have to go in order. You just got to state them. RS is congruent to AT. So I'm going to now put a tick mark on RS and AT. Line 4, they say we're going to use a reflexive statement. That would go with which part? Yep, RT, the shared side. So RT is congruent to RT. Now, line 5 wants us to prove the triangle, are congruent. I have to pick one of those 5 ways. Triangle ART, this triangle here, would be congruent to STR. If you need to, you can put in your letters. Sorry. This is an A. This is a side. There's the other sides. Which one would this be? Yep, side, angle, side. And so our last line talking about the side RA and ST. What's our reason for this line 6? Yeah, CPCTC. All right, number 5. Number 1, always given. And if you look, they're talking about MV and HA. So tick mark, tick mark. They also want the second given statement. That was here, meaning your MA segment is congruent to your HV segment. MA, tick mark, tick mark. They're referring to this diagonal here, MA and HV. Now, line 3 says VA is congruent to AV. That's the same segment, the same expression. That is this part here. This is reflexive. There's the shared side. Actually, there should be 2. I forgot to put 2 here. So what would these 2 triangles be congruent by? Which of the 5 ways? Triple sides, yes, SSS. Good. Okay. I want you to try number 6, and then we're gonna move on to the back. But I want you to at least come on. Let's see if you can start and finish. I'll pause a little bit longer to let you fill in. But you need to try to take some risk and see if you get it. Pause this. Check if you're on the right track so far. Make sure if it's a given, you also mark it on the diagram. That's the way you're going to be able to see one of the 5 postulates. Line 3 should be using a reflexive property because you have a shared side. So you have to state that side OS is congruent to OS. Hopefully we got 4 to be side, side, side. Which means now I can prove line 5, angle H and I congruent by C, P, C, T, C.